Linear regression can predict values, but prediction is the easy part. The real magic is training. How does a model go from random guesses to accurate predictions? How do weights automatically improve? And how does AI actually learn from mistake? In this video, we are breaking down the entire training process of linear regression from loss functions and gradients to gradient descents and weight updates. And we'll also be implementing it in Python. Training is basically repeated error correction. The model predicts, measures how wrong it was, then adjusts its weights to do better next time. That simple loop is the foundation of machine learning. At the beginning, the model knows absolutely nothing. Weights are random, predictions are terrible. Training slowly transforms those random weights into meaningful patterns learned from data. Every learning step starts with one thing: comparing prediction with reality. The difference between them is called error, and that error becomes the signal that tells the model how to improve. But a model needs a single number to measure overall performance. That's where mean squared error comes in. Mean squared error, or MSE, squares the error and averages them together. Big mistakes get punished more heavily, which forces the model to improve faster. Now the model knows it made a mistake, but how does it know which direction to move? That's the job of gradients. Gradients tell the model how loss changes when weights change. In simple terms, they point towards improvement. Here comes the core learning rule behind modern AI: weights, which get updated using gradient descent. The model moves step by step in the opposite direction of the gradient to reduce loss. Small updates repeated thousands of times. That's how learning happens. And this entire process keeps repeating. Forward pass, compute loss, calculate gradients, update weights. Again and again and again until predictions become accurate. As training progresses, loss starts decreasing. Predictions become closer to the actual values, and eventually the model converges toward a much better solution. Now that we have actually learnt about how linear regression model trains, let's now implement it in Python. So this is the problem description given, and this is the code that we are given with. So in this solution class, we are given with get derivative, which gives the derivative of the inputs we give while giving the function parameters. Next, we have get model prediction, which also takes some inputs as parameters and gives us the prediction. Learning rate is a global variable, and then we have to implement train model function. So train model function takes x and y as the input, number of iterations, and initial weights as the input. Now, how we are going to implement it? So for each iteration, we are going to compute predictions with get model prediction function, which we have seen above. For each weight index j, we are going to compute gradient using the function get derivative, which we also saw above. And then we are going to update each weight using the formula weights at the jth index is equal to weights at the jth index minus learning rate times gradient. And finally, we are going to return numpy array rounded to 5 decimal places. Let's begin. Let's begin. So for underscore n range number of iterations, we are going to make predictions. So predictions equal to self dot. Now we are going to use this function get model prediction. Self dot get model prediction, and then we are going to give it x and initial weights. Yes. So after that, we are going to compute the gradient for each index of it. So for j in range length of initial weights, after this gradient is equals to self dot get derivative. This function was defined above as we have seen, and then we are going to take model prediction, this one, and next parameter is ground truth. After that n is nothing but the length of x, after that x, and after that desired weight. So first was model prediction, which is predictions from here. After that ground truth, which is y, given in the function parameter. After that we are going to take length of x, then we are going to take x, and then desired weight is nothing but the j, value of j. Let's check. Yeah, it's correct. And after that we have to change the initial weights using this formula. So initial weights is equals to initial weights minus, initial weights of j, and then we will be reducing it by gradient times self dot learning rate. You can see the learning rate is defined in the class, that's why we are using self. After that, just return np dot round initial weights round to 5 decimal places. Let's run the solution. Yes, the test cases are running fine. Let's submit it. And yeah, the implementation is done successfully. And that's the complete training pipeline behind linear regression. This exact idea, loss, gradients, and weight updates is the same foundation behind neural networks, deep learning, and even larger language models. If this video helped you understanding training, gradients, and loss functions better, make sure to like the video and subscribe for more such videos. See you in the next one.